Good afternoon, guys. I hope you guys are doing well. Okay. Today we will be looking at STTN121 test one preparation. STTN121 test one preparation. Okay. I hope. Okay, I just want to check something here. Okay, let me share my screen. This is the one. Okay. All right. Okay, let's see there. Okay. All right. Let me put this one there. Okay, put it here. Back. Okay. Um, STTN, the first chapter, it's chapter 8. So, I believe that students who are doing STTN 121 this semester, second semester, last semester they did STTN 111. And the last chapter on STTN 111, excluding that one of chapter 12, which was theory. The last chapter, it was chapter 8. So I believe that you know how to calculate the probability, the continuous probabilities, the central limit theorem. You know how to calculate the probability of an event. But in this one, we'll explain more how to get those probabilities. We'll also discuss how to get the chi-square interesting, the F table, and also the binomial distribution. Believe that you guys are also doing your binomial distribution and also De Morgan's law. Okay, so under this one, see something here. All right. Okay, starting with 8. So now we need to know how to do this. So now when we start with the introduction, the review, what is that one? The review of set notation, the basic probability concept, the tools for counting individual outcomes, the conditional probability, and so on. So guys, the reason why I had to do a video is because other students they said I must do a video on 121 because my videos they really helped you guys last semester. So yeah, this one will be test one preparation. I'm just gonna explain how to get the probabilities, like I said, the F tables and so on. So now we're gonna check the one for the review of the set notation, the basic probability concepts, the tools for counting individual outcomes, the one for the permutations, the combinations, the conditional probability, and also the independence of events. So after doing those study units, then I will open at least one or two question papers and explain them. But the only question, the two, I think I have two or three question papers, but it's only question paper plus memo, so it's included. Like with the STTN 111 for test one, test two, we don't have the question paper without the memo when you download them. So unfortunately, I only have the question paper and memo. But I'm going to explain how they got those answers so that you guys can be able to understand. Because you can have the question paper plus memo, but you don't understand how they got those answers. The most important thing with stats, you need to understand the basic. It's very important that you guys understand the basics. That is what I'm doing here. You need to understand the basics. So we're gonna check. And then the other one will be conditional probability and the independence, the random variables, the probability distribution of a continuous random variable, the normal probability distribution, and also the sampling distribution and the central limit theorem. And then after it will be which one? Uh, it's gonna be the tools, okay, the loss of probability, random variables, and so on. Okay, just wanna confirm something. Random variables also do that. And then it's gonna be probability, the continuous random variables, and then the normal probability distribution. And then where's the other one? Then the sampling distribution, obviously this one. Okay, the other one is the chi-square, the F table. So I believe that it covers your test one. And then, okay, these are the question papers. Okay, start from here. All right. Okay. The introduction. I believe you guys, when you were doing STTN121 last semester, you did chapter 8. You did probability. You know that with the probability, we measure, because you know the definition of probability. You need to understand what is probability. So, for example, you guys, when you're doing STTN121, let's recall back to STTN121. Sometimes they will give you um an event, or they will tell you that you toss a coin, and then what are the sample space. You need to find the sample space. You need to find the probability of tossing the coin. That would be maybe the event of tossing. Maybe it's going to be the heads and it's going to be the tail. So with this one, the probability, you show that it's when you measure of the trust where an individual places on the occurrence of a future event. And also, this is very important, the probability value is always between 0 and 1. You cannot get a probability of more than 1, maybe 1.3, 1.5, 1.7, 2 point something. You see, you cannot get that probability. And a negative probability, you cannot get that. It's between 0 and 1. You'll see when you do the questions. Okay, they say that a random event, it's very likely to happen if its probability is close to 1. This one, it's very likely to happen. But it is not likely to happen if that probability is close to 0. Yeah, please note this one. Okay, let's go to this one. 8.1, that's the introduction. I'm going to go to the one where we are given a scenario. Just want to show you something. Because I think the best way is for me to start by explaining using the slides. Okay. All right. Let's see in triple one, chapter. It was chapter 3. Yeah, chapter 3. You guys, you did the relative frequency. You know that the relative frequency is the frequency divided by n. We did this one. Okay, but I just want to start one. Okay, there's something else I want so that you guys can be able to understand. Okay. Okay, oh no, not this one. Yeah, I'm looking for this one of the set of notation. This is very important. This one. So, okay, guys, please check this. Let's check. One, if the elements in set A are A1, A2, A3, then we'll write the elements as this. As the set. But this simple, it means that we have the set of all elements, or sometimes they call it the universal set. This one is an empty set. This one, this symbol, it shows that A is the subset of B, or that A is contained in B. You will see like we would when we do the questions. Okay. Then this one is a union. It means the probability of, it means A union B. This union, also we can use OR. We want OR. We can use OR. So please also check out that this one, it's the intersection, it's AND. The intersection of A and B, it's AND. We use AND here with this one. Now this one, A, it's a complement, the complement of A. So when they calculate, for example, if they say, just want to show you something. Let's say, for example, you are given, let's say, for example, you are given the probability of A like this. You are given the probability of A as maybe 0.70. And then they tell you, okay, you must calculate the complement of it. It's gonna be probability of, okay, the probability of A. I'm gonna put the complement there. Gonna be the complement, which is they put C. But other students, they put something like something like this. They put something like this, then they put this here. This. Some they put C. It's the same thing. The complement. So how do you get this one here? It's gonna be which, okay, which is equal to 1 minus 0.70. And then I think you'll get 0.30, the probability, the complement of that, which is 0.30. Yeah, because if you say 1 minus 0.70, you'll get 0.3. Yeah. And 0.3 is the same as 0.30. So this is how you get the okay, let me just put it like that. This is how you get this complement. The squares complement this one. And then A and B, when they say that the probability of A and the intersection B is equal to the empty set or the null set, it means that A and B are mutually exclusive. And also, it is very important to know how to prove that events A and B are independent, dependent events, they are mutually exclusive or non-mutually exclusive events. So we'll discuss that. Okay, let's see. We have a definition of a set, which they say here in this case, they say that a set is a well or a clearly defined specified collection of distinct elements or objects. For example, if we are given a universal set, remember we said this is universal set or the set of elements. For example, if you are given the universal set or the set of elements as 1, 2, 3 till 10, which is here it's 4, 5, 6, 7, 8. Okay. And then A, we say it's 3 and 5. B, it's 1, 2, 3, 4, 5, 6. And C, it's 1, 3, 5, 7, 9. Then we say that A is the subset of B. Why are we saying that A is a subset of B? Why? On A, we have 3 and 5. On B, there's also 3 and 5. That's why they say that A is contained in B. Let's go back here so that we can see. A is contained in B. You see, and B includes A. So the reason why they say that A is the subset of B, it means that on A we have 3 and 5, but when you go to B, you will see 3 and 5 again. It's also there. But note that also A is a subset of C. Why are they saying that A is also a subset of C? Because under A we have 3 and 5, but when you go to C, you have 3 and 5. So A is also a subset of C. Please also check that. It's also a subset of C. Very important to check that. Okay, I hope you understood that. Now let's check the part of union. How do they calculate this? But remember, they will give you a probability. There will be a question where they will give you a probability where they will say calculate the probability of A union B, calculate the probability of A union C, calculate the probability of A, what those kind of things. Yeah. Then I'm going to show you how to do that. So now let's check this one when they say that it's a complement. I mean a union, A union B. I mean B union C. How to get that? B union C. Let's check how did they get that? So this is what they do. When you check our set, it starts from 1 to 10. Our values there. Now B union C, you are going to include, you see under B we have 1, 2, 1, 2 till 6, and then C is 1 till 9. You see we have 1 here and 1 this side. 2 this side, we have 3, 3. 4, we have 5, 5. We have 6, 7, and 9. You see. So with B union C, you're going to include the values that are on B and C, which it's 1 is there, 2, 3, 4, 5, 6, 7, and 9. You see 1, 2, 3, 4, 5, 6, 7, and 9. Because already 1 is here, 3 is here, 5 is here. So you don't have to say 5, 5. No. 1, 2, 3, 4, 5, 6, 7, and 9. That's how you get the B union C. And then what's the other one? Then now to get the intersection. Remember the intersection, it's A and B. The intersection is this symbol. And this symbol, it's an intersection symbol. So when if they say B and C, to get the intersection of B and C, you're going to check. This is where they intersect. On 1, where they are repeating. On 3, on 5. You're just gonna say 1, 3, 5. Because here this side we have 1, we have 3, we have 5. This is where they intersect. B and C is where they intersect. That's the reason why they said it's 1, 3, and 5 here. So if they give you the universal set or the set of all elements, and then they tell you to find the probability of B, or no, not the probability, B and C, which is the thing, the intersection, you need to check here on the set. Okay, that one. Then you also have the Venn diagram. So the Venn diagram, it's A union B. This is A is the subset of B. I think I've explained that one on the previous section on how do you see that A is the subset of B. The Venn diagram will be like this, and you need to know how to draw the Venn diagram. This is where you find A union B. This is the Venn diagram. A is going to be this one, and B is going to be this one. This is how you find A union B. Okay. Okay. Then you see this part here. This is where they intersect. This is where you're going to get the intersection. Where this part, where you're going to get the intersection. Now, if A and B is equal to the empty set here, it means that it's going to be separate. This one, you won't get the intersection. You see this one, there's no intersection on this one. So yeah. And then this is the Venn diagram of the complement. I also explained how to get this complement, the probability of this complement. So yeah, let's look at the example. This one. We're given the set or the sum of the set of L elements 1 to 6. So we have A is 2, 4, 6, and then B is 5 and 6. The reason why we don't have the union between A and C, because we have 2, 4, 6, but here on we don't have the values that are in A or that are the values in A that are in B. You see, because 6 here it's and 6 here. But then when you check B and C, it's 5 and 6, and then C is 1, 3. So meaning it's what we call the overlapping cycles, non-overlapping cycles. Because it's gonna be like now A and C, they are mutually exclusive. When they are mutually exclusive, it's gonna be A separate and then C separate. There's no intersection here. I've showed you guys how to find the intersection. The intersection is where both, when you check on the A and B, both that they are there. For example, you saw on that question, it was 1, 3, 5 on this one. It was 1, 3, 5 on this one. You see 1, 3, 5, both of them. This is where you're going to find the intersection. So even that one here. So here on this one, we have A, B, C. When you check A, they correspond where, there's intersection on C, on A and B, on 6 and 6. Because there's 6 here, there's also 6 here. So this is the intersection where you're gonna find the intersection. And when you check between B and C, we have the intersection of 5 and 5. Here it is. 5 and 5. This is where you're gonna find the intersection between the A and B and C on that one. Okay, now I think this one, there's no need for me to explain this one because I think I've already explained the intersections and the unions. So this is very important. They say that if you are dealing with the distributive laws, A intersect, then open bracket B union C, it will be A and B because of this. It's like A, this symbol multiplied by B, you will get this. And then A, this symbol, which is and multiplied by C, you will get this here. But this symbol, the union, is this one here, the one that you see here. This is the one that you see here. Then here, A union multiplied by B, it's A union B. And then A union multiplied by C, it's A union C. The intersection, this is the intersection here. It's still there, the intersection. You don't change it. Yeah. And then De Morgan's law. Then for De Morgan's law, we say that A and B, with the intersection, both of them, the complement is equal to A multiplied by the complement, here it is. Then B complement, here it is. Then if here is the intersection, it means you're going to replace it with the union. If here is the union, you're going to replace it with the intersection. It's going to be A complement here, and then B complement here, like this. You'll see when we do the thing. Then now, this is the one, done with this. Then now it's the basic probability concept. Let's go and check the basic probability concept. When you guys were doing STTN121 last semester, you did the concept of the experiment. You know that the experiment, they're talking about the process of making an observation, or it's when you are taking a measurement, and that measurement, remember, will lead to what we call a collection of the outcomes, where you have to find the sample space on this one. For example, you can flip over a coin and the roll of a die. Okay, let's check. I believe now you all know the sample space. And then this is the how would you find the sample space? But let's check question. We can also have, also don't forget the definitions. The definition of the event, which is the any subset of the sample space, which is called the event. Then let's check what's the other one. Just want to show you something. The one that I know that people too. Okay. This I remember this example, it's from STTN121. Once you find because I'll focus more on explaining the question papers. Once you find, and also explaining the summary notes of this. Once you find the sample space, which is, I believe it's 8, 1, 2, 3, 4, 4, 5, 6, 7, 8. The sample space, which is equal to 8. Now, you will be given the probability where they will be like, okay, find the probability of event A. Exactly 2 of the 3 hit with gas. Exactly 2 of the 3. Well, now when you check, exactly 2, this is the one, GG, where it's 2G, 2Gs, GG here and GG here, which is 3. So it's going to be 3 divided by 8 to get the probability of this. If they say the probability, same applies to this one, it's going to be 3 divided by 8 to get the probability. This one is going to be 1 divided by 8 to get the probability. And remember, the probability is between 0 and 1. Okay, let's go and check. So yeah, this is how you do it. This is the formula. This is the formula. NA is the number of outcomes in A, and this is the sample space, or the number of the total outcomes. So I believe you did this one. You defined the experiment. I also explained the outcomes of the event. You'll see when you do the questions and the probability of the outcomes. And also this one, yeah, focus more on the relations. But this one, I think I explained it on how did they find the probability. See, 3 divided by 8, 3 divided by 8 to 1 divided by 8, and another one. Okay, with the other one. And then this is like when you calculate the probability of an event, remember it has to be between 0 and 1. I think I said this one. And you will understand this one when we do the random variables. So when you add them, they must give you 1. When you add the probabilities of the function, they must give you 1. You understand this one when you reach that part. So yeah, and then where's the other one? This is an example that you can do, self-evaluation exercise. And then focus more on this one, because I believe that most students, they are struggling with the counting individuals, the permutations and the combinations. I think under 8.4. Yeah, 8.4. 8.4, this is the one. So now, okay, let's go to this one. Okay, on your calculator, we have this symbol, it's there. The factorial notation, this symbol, this one, it's there. So if you want to find maybe 5 factorial on your calculator, you just punch 5. You also shift, you check that factorial there. It's x to the power -1 on your side. It's x to the power -1. Something like this. X and then to the power and then -1 on your side. You'll find some, but you are not on your side, you'll say shift and you press this pattern. It's gonna turn into factorial. And then you say 5 factorial, then you'll get 120, so on. But let's check. We are given the questions and see. Okay, let's say, let's focus more on which one? Get the questions where we are dealing with the permutations. Okay, this is the permutations. We are dealing with an ordered arrangement of R, where R is the distant objects. We call it the permutations. Now, the possible permutation, which is R for distance objects, which it goes with the factorial. This is the formula that we're going to use. You say that the permutations, it's n factorial divided by n minus R. What is this value of R? R, remember, we are talking about the distance objects, okay? Note that Okay, this one is n permutation. Okay, we'll look at the question so that you can see. They say, how many different letters or different ways? No, different ways. These are the kind of questions that they will give you in the test or in the exam. Can the letters A, B, C be arranged? Let's check. For that question, in how many different ways can the letters A, B, C be arranged? You need to check. If we can arrange these letters 6 ways. If you try to find it, it will be like A, B, C. They said how many letters? Let's check. A, B, C, A, B, C only. So if you check, if you arrange this, it's like you are finding the outcomes, like you write them as the outcomes. But at the end, you'll end up getting the 6. You'll end up getting the 6. Okay, let me show you another one. The one I'm talking about. The permutation was still the same thing. What's the other one that I want to show you? Where is it? Where is it? Where is it? Where is it? I wonder where there's exercise before we do the question papers. There was a question. Okay, there's something like that. Okay, for example, I think you guys will be able to understand this. Okay, they say how many ways can the blue Bulls rugby team schedule 3 games if all competing teams are willing to play the matches on any of the 5 dates? The question is, what is the value of n? On n, it means that n will be the 5 dates, which is 5 factorial. Remember, r is the distance objects, the one where it means that on the rugby team, schedule 3 games. So it's going to be 5 minus that 3. And then you'll get 60. Or you can say 5, and then you go to your calculator. For you to find the permutation, you see on the multiply by, you press shift, you press that multiply by, it's going to turn into P, which is permutation. So you can just say 5, you say shift, you go to that multiply by, it's going to turn into P, you say 3, you press equal sign, you get 60. So yeah. So that's how you do it. But I'll focus more on explaining the questions. Now, you saw how they calculate the permutations. Now we go to the combinations. Now, the combinations, it's when you are dealing with the number of possible unordered sets of R objects, which is chosen without replacement. This is the formula that we use to calculate the one for the combinations. N factorial into R factorial into N minus R factorial. Let's look at the way they ask the question so that you can be able to see. Okay, let me show you something. Okay. Okay, they can give you something like this. They say, this is the example. Given the set of letters A, B, C, D, you write the number of combinations of the 3 letters, which is A, B, C, D. Now, remember, it's 1, 2, 3, 4. It's the N is 4 letters. But remember, what they're telling you, write the number of the combination of 3 letters. The 3 will be R. N is 4. So now, to get the combinations of this, you can just say 4, and to get this C on the calculator on Casio, it's the division sign. You say 4, and then after you say shift, you press that division, it's going to turn into C. And then you press 3. I mean, you say 3, then you press equal sign, you will get 4 in this case. Okay, this is how you can arrange it. This is how you can arrange it. Which it will give you 24 different arrangements when you count them. It's like when you find the number of the tosses, you might find maybe 8 when you're busy with the calculation. Make sure that you understand the question. And then what's the other one that I can show you and where there's the calculations? Focus on which one? Yeah, this one here. I believe it's 8.14, 8.4. No, this one is 8.14. I just want to show you guys. Okay, let's check. They say, okay, for EG, we have 5 qualified applicants. Remember, what is the value of N? 5. For 2 editorial positions, what is R? 2 here. Okay. Now, the sample space for this one, we can just say 5 combination 2. And I believe you'll get 10. You'll get 10. I think. Let me verify on my side. 5 combination 2. Yeah, you get 10. For this one, 5 combination 2. Now, they say, now let the event that neither of the men, the keyword, always check out the keyword, or no man was selected. So since we have under the two editorial positions, we have the two editorial positions. They don't select anyone, remember. So it's gonna be 2 combination 0. This thing is like 2 combination 0. Plus, now remember that 3 comes from 5 minus 2, which will be 3. Combination the two editorial positions, which was going to be, I think I explained this one and this one, you will get 3 ways. Then to get the probability, you're going to say that 3 divided by the total samples or the sample space, which is 10, and then you will get 0.3 on this one. So yeah, that's how you get the thing. Some of the questions, I'll explain them when we do the question papers. And then what's the other one? To show you guys so they can explain. Okay, the difference, because I believe there will be the student asking, what is the difference? How do you see, if you're given a question, how do you see that this question is based on permutation, and how do you see that the question is based on the combination? Look at this. We're given a data like this, 13579. They say suppose that we select all possible 2, the number of arrangements. Under the permutations, guys, the order where you select, the order is very important here. The order is very important. Now, but then with the combinations, they say it's the same question. With the combination, we select all possible 2 here. The number of arrangement, the number of combination is long, meaning with the permutations, you are dealing with the number of arrangements. With the combinations, you are dealing with the number of the combinations. So with the combinations, the order of you like selecting is not important. Meaning, for example, they say that the order of selection is of no significance, like this. Then this is what will be the permutation. The symbol of the permutation is P. Then this one is the symbol of the combination, which is C. And then which we're gonna get this time is 20. This one is 10. The other one has R. The one doesn't have R. The one with R is the combination one. The one with P doesn't have R. That's how you get the difference. Okay. I think we're gonna go to the loss of probability. This is very important now. Please check this. This is the formula of the mutual exclusive event. The probability of A union B is equal to the probability of A plus the probability of B. This is the formula for mutual exclusive event. So I'm just gonna show you the basics, then we do the questions. Then this is I think I've explained this one on the first section. Actually, I've explained this formula, the complement law. Those formulas are very important. I've showed you the one for mutual exclusive event. Now you see the one for the complement events, which is 1 minus the probability of A. This one here. 1 minus the probability of A. And then what's the other one? Then this is the formula for non-mutual exclusive event. This is the formula that you use for non-mutual exclusive event. By saying the probability of A union B is equal to probability of A plus the probability of B minus probability of A and B. Now you know the symbols that this one is for intersection, this one is for union. So it's very important to check that. You'll see when we do the questions. And then this is the same formula. I think I did this one. What's the other one? And then this one is the intersection, the formula of the intersection. This one you can also, the probability of A and B is equal to probability of A multiplied by probability of B. You can also use that formula for the intersection. Let's see. Then I think we'll move to the random variables. Then after we do the questions. So this is the random variables. Let's see. Okay, interesting. Let's see. The random variables on this one. Let me do this. Then after we'll do the questions. The random variables, they say it's very important to know the definition of a random variable. Random variable X associates a numerical value to each individual outcome of an experiment. This is the definition of the random variable. For example, this is very important. I'm going to show you something. Consider X to be the number. Consider X to be the number of heads obtained here. The first one. Obtained. The second one. In 3 tosses of a coin. The second one. Now, when you look at this, list the numerical values of X and the corresponding individual outcomes. This is what we call a random variable table. This is how you write it. Someone will be like, okay, how do you know that X is equal to 0? And how do you know that? Okay, let me do this. Okay, someone will be like, how do you know that X is equal to 0 and X is equal to the thing? Okay, let me just do this. Okay, where is it? Okay, how do you know that X is equal to 0 and also X is equal to 1, 2, and 3, and so on? How do you know that? How do you know that? Let me do this. Okay, it's fine. Same thing. Okay. Okay, let me try to do it like this. How do you know that? Okay, guys, now check. This is what you do, ne? First, find the sample space. You know that when you find it, agree when they say 3 choices, you know that we can have heads, 3. Heads, tail. Heads, tail, heads, tail, heads. How you arrange them, ne? Okay, the last one will be tail, tail, something like that, ne? You also get tail, head, tail, head, tail, head. Okay, no problem. Important. Now, remember, the instruction says X to be the number of heads obtained. If X is equal to 1, it means the heads has to be 1 head. You see 1 head here, 1 head here, and 1 head. You're gonna write this event because where X is equal to 1, according to the instruction, the number of heads obtained, you're gonna focus on, if it's 1, head has to be 1, 1, 1. You're gonna you're gonna write that event where head is 1, 1, 1, 1. But if the reason why X is equal to 0, we have tail, triple tail, is because the question focuses on the number of heads obtained, not the tail, not the number of the tails obtained. So that doesn't, under 0, you can have triple tails. When X is equal to 2, you're gonna have 2 tails. I mean two heads, which is 1, 2, 1, 2, 1, 2, 2 heads. When X is equal to 3, because now this time you're gonna have 3 heads, which is this one. This one. If now they tell you to calculate the probability where X is equal to 1, you'll be like 1, 2, 3. 3 divided by the sample space is what? 8. How do you get 8? 1, 2, 3, 4, 5, 6, 7, 8. The 3 choices, the sample space is equal to 8. You'll get, for X is equal to 1, you get 3 or out of 8. This one, 3 out of 8. This one, 1 out of 8. This one, 1 out of 8. That's how you do it. So this is how you get the sample space here for 3 choices. I think you did it there on STTN121, but you didn't do the one for the random variables for how to draw this table of a random. But remember, the table was there. But now this is how you draw it, because they can ask you to draw this table. Yeah. So I think I also explained the random variable definition. And then now we are on the probability distribution of a discrete, and also the one for the continuous. Now the probability distribution of a discrete random variable, interesting. So meaning there'll be 2 videos. The first one, it's where I do the summary of, maybe it can be 3 videos because I'm gonna put them like short. Gonna be the first one where I discuss the summary notes, and then the second one maybe is gonna be continuous of what I was discussing. The third one is gonna be doing the question papers. Now look at this. The probability distribution of a discrete random variable. They say that the probability distribution of that discrete random variable X is a list of the distinct numerical values of x with the associated probabilities. Interesting. This is how you, okay, this is the table that I was talking about. Okay, where x is equal to 0, 1, 2, 3. I think I've already explained this one. This one's going to be 1 divided by 8, 3 divided by 8, 3 divided by 8, 1 divided by 8. Now, check. You remember there was a, I think that's probability rules and so on, where they said it when you add them, they must give you one. It is this one where I said I'm going to explain it, you're going to understand it. When you add this whole thing, it must give you one. You will see the table that I'm talking about. They will give you a probability table, and then on the table, under the discrete random variable, maybe under the maybe x is equal to 3, they give you the question mark, and then they tell you to find that one. I'm going to show you how to do those kind of questions. So this is what you call the probability function for x1, and then when you add all of them, they must give you 1. Then yeah, this is the one. This properties that are very important. Probability distribution or the probability mass function. This is the one where you want to see the table that I'm talking about. It's between 0 and 1. Probability function is between 0 and 1. When you sum all of them, when you add all of them, they must give you 1. Don't forget this properties. We just say probability function is between 0 and 1. And then when you add all of them, they must give you 1. And then what's the other one? This is how you do it. You add all of them, they will give you 1. Okay, what's the other one? What's the other one? Okay. This is the one, at least 2. You start with 2, 3, 4, and so on. It's very important. At least 2. This symbol is for at least. Greater or equal to is at least. Even this one. Okay, let's go and check. Okay, this is okay. Focus more on the other one. Where is it? All right. Again, another random variables. These are the formulas under the probability distribution of a discrete random variable. We have a formula of expected value, which is the population mean. The expected value is U, which is EX. Expected value is EX. I'm going to show you how to calculate this one. Just write down the formula, the summation, xi multiplied by the probability function. Interesting. Huh? To calculate the expected value is very easy. Now, the population variance. To calculate the population variance, it's this simple, or you can just say var x is equal to the x minus that expected value that you've calculated squared multiplied by the probability function. Even this one is simple. Once you get, you know that once you get the variance, for you to get the standard deviation, you need to do a square root of that variance. I'm going to show you how to do this. Okay. I'll show you when we're given a table. Not this one. Don't want this one. Okay. This I think I discussed this one. I'm going to show you on the question papers. I think it's going to be the question on how to get that. Even this one, how to get this one. Okay. Are we? This one, okay. It's still the same thing, but I'm going to show you how to do that. Then I think now we are on the binomial distribution. The binomial distribution. So the binomial distribution, you need to understand that they use what you call a Bernoulli population, which is a population in which each element is one of the two possibilities. What are those two possibilities? There's either success or failure. Then we also have what we call the Bernoulli triad. It's that one, we use it like observing one element in that Bernoulli population. Then also understand this definition and also this one. Now we have what we call binomial experiment. What is a binomial experiment? On this one, they say that it's an experiment that consists of n repeated independent Bernoulli triads, in which the probability of that success on each triad, which is, we used to call this the population, it was proportion. Yeah, we used to call this population proportion. And then the probability of failure on each trial is 1 minus the population proportion. Okay, let's show you how to calculate that. For this one, I have this other formula. I think it's from students who are studying at UNISA. I saw it there, but I will advise you guys to stick with this one because it's there on the formula sheet. It's n, the k is the number of the success, and then the pi. I'm going to show you how to find this. Sometimes they call it the pi, the population proportion to the power k. into 1 minus the pi, close bracket, n minus k. Can show how to the when we do the questions. And then what's the other one? I can show you. Okay. This question, let's look at this one. What is the probability that in 12 flips of a fair coin, exactly 4 heads will result? So the probability of x is equal to 4 because it's exactly. When they say exactly a certain number, 2, 4, 5, you use equal sign. 12, it's n. And then combination, because it's, I've showed you guys the formula. This is the formula. N, K, and then also the other one. So it's going to be combination 4 into why 0.5? They told you could now the 4 success out of 12, which is now for the single toes, it's going to be 1 out of 12, one of the other out of 2. But when on the test, they will give you a question where they will tell you or go to something like this: pi is equal to 0.4, n is 10, and so on. Then that's how you're going to calculate it. They're going to give you something like this, which you find that the probability that 6 of the 10 prisoners are successfully rehabilitated, and this one that no more than 2. Those are the kind of things that will give you. So you know that this is the formula that we're going to use. Now, n10, k6, pi 0.4. I'm going to explain this kind of questions in this one when you substitute. So obviously here on n, it's going to be 10 combination 6. Here 10 combination 6 into 0.4 is this one, because according to the formula, to the power, what is k? It's 6 into 1 minus 0.4. That's the reason why they got 0.6. Close bracket, n minus k, which is 10 minus 4. You'll get 0. You get, okay, wait, 10 or 10 minus 6, yeah, because it's n minus k, and then we get 4. Then they got the probability of 0.11111 something. This one, this one is the symbol for exactly, equal sign. This one, less or equal to, it's at most. They use it for at most. If they say call the probability of at most what, then yeah. Or they use the symbol for no more than. It can be at most or no more than. You can write it down. They use this symbol, and then you substitute. If they say at most 2, it means that if they say at most 2, start with 0, 1, and end with that number that they mentioned, which is 2. If they say no more than 2, same thing. You always start with 0, you end with the number that they mentioned. If they say at most 5, you start with 0, you end with 5. And then that's how you do it. And then what's the other one? This is the question. The question will be something like this, where they will say, okay, you can see this 10% is the one where I said is pi, or the population proportion. And then n will be 50. And then they say exactly 5. So probability where x is equal to 5. You will use this formula, this one. And then you substitute. But first, you need to write, okay, pi is equal to this one, n is equal to this one, x is equal to this one. That way, you will be able to get this option A and B correct. At least 2, you're going to start with 2, 2, 3, 4, 5, and so on. Same applies to this one. You'll see when we do the questions. So you see binomial probability under the Bernoulli population is very interesting. So what is the other one? Same thing. It's very interesting. Is it? Okay. So you saw that when we were doing the random variables, the probability continuous under the discrete random variables, we had the formula for expected value, we had the formula for the variance, we had the formula for the standard deviation under the discrete random variable, the random variables. But now here on this one here, we have another formulas. We have another formulas for expected value, which is n multiplied by pi. Interesting. They will give you n, they will give you pi. Then they tell you to calculate the expected value of what? The expected value of the binomial probability distribution. We just say that n multiplied by the pi. If they say they want the variance, you say n multiplied by the pi, open bracket 1 minus pi. You get this. If they say they want the standard deviation, you do a square root of this here to get the standard deviation. These three formulas under these three formulas under the probability of the binomial experiment. This thing. Number one, they will give you n is equal to 10, pi is equal to 0.2. They tell you to find the ex, which is n multiplied by the pi, which is 10 multiplied by 0.2. And you get 2. To get the variance, it's 10 multiplied by 0.2 into 1 minus 0.2. And then you will get 1.6. Then to get the standard deviation, you're going to do a square root of this 1.6. We didn't get the standard deviation. So the next one will be the probability, the continuous random variables. So this one, let's see. I want to check if already I talked about this one. No, I didn't talk about this one. The continuous random variable. So, okay, let me check something. So I'm gonna make this one STTN121 test one revision part 1. This one will be part 1. And then I'm gonna continue from this one. It's gonna be the part 2. I'm gonna send it soon in part 2. So yeah.